Let's now fill in the missing values of this table. So here the interest is compounded continuously. So I'm going to use this formula for compound interest when it is compounded continuously. So this formula gives the value of amount after t years, that is a equal to p times of e raised to the power of t, where a is the amount after t units. It could be in years or weeks or days, something like that. And r is the rate of interest in decimal, t is the time, and e is the Euler's number, approximately 2.718281. So let's replace this formula to fill in the missing values. Let's identify the information which we already know. So initial investment, this is P, therefore P equal to 600, and this is amount after 10 years, so A equal to 1705, and this time equal to T equal to 10. So we have all this information. Let's plug in into the formula to determine the annual rate of interest. That is, we will find R first. So I'm going to do that. For A, I'm plugging 1705 equals P is 600, e raised to the power of r we have to find, and t is 10. So r times of 10. Now we can divide both sides by 600. So we'll be getting 1705 over 600 equal to e raised to the power of 10r. Now we can further simplify this to solve for r. I'm going to take natural logarithm on both sides. So when I do that, I'll be getting natural logarithm of 1705 over 600 equal to natural logarithm of e raised to the power of 10r. Now we can see that we can apply the property of natural logarithm. That is, suppose if we have natural logarithm of x raised to the power of y, this could be simplified as this y comes in front, so it gets multiplied with y times of natural logarithm of x. So in this case, so if we apply the property, this is this 10r comes in front, multiplied with the natural logarithm of e. Also, the natural logarithm of e equal to 1. So which means this natural logarithm of e could be replaced as 1. So it becomes 10r times of 1. So therefore this becomes 10r. And so to solve for r, we have to divide both sides by 10. So let me write r by itself. This is equal to natural logarithm of 1705 over 600 divided by 10. We can plug this into the calculator, and when we do that, we approximately get a value of 0.1044. We can convert this into percentage. So we just have to multiply by 100 to convert into percentage. When you do that, we get approximately 10.44%. So this is the rate of interest, that is the annual rate of interest. We can put this into the table, 10.44 in terms of percentage. So this is already in percent. We can also put percent over here. Now let's fill in the other missing value. That is, we have to find the time to double in years. So let's see how to do this one. It's basically time to double. And this means, suppose if we have an initial amount of P, the double the amount will be 2 times of P. So either we can plug it like this, or you can use the values which we already know as the P. The P value is 600, which means I substitute 600 for P, and for A, that is the double of this amount, 2 times of P, and this is equal to 1200. So once again, I'm going to plug that into the formula. Let me write the formula here. A equal to P e raised to the power of 40. So I'm plugging 1200 into this, and P equal to 600 e raised to the power of r we just found out, that is 10.44%. So we have to use the decimal form. So I substitute 0.1044 times t. This is what we have to find. So we just put it as t. Now from this equation we can solve for t. First I divide both sides by 600, and when I do that I get divide by 600 divide by 600. So basically this is 2 on this side, and I'll be getting e raised to the power of 0.1044 t. Now to solve for t, we have to take natural logarithm on both sides. So when we do that, we get natural logarithm of 2 equals 0.1044. Once again, it becomes natural logarithm of, sorry, this, I just went ahead. So when I take the natural logarithm, I can write down this as natural logarithm of e raised to the power of 0.1044 t. Now using the previous property, this power comes in front, so therefore this will become 0.1044 t multiplied with the natural logarithm of e. We already know that natural logarithm of e is 1. So 1 times of this 0.0144 t is just the same value. So this side we have natural logarithm of 2. Now we divide both sides by 0.1044, that is this quantity, so can solve by t. So therefore t equals natural logarithm of 2 over 0.1044. We plug this into the calculator, and when we do that, we approximately get the value of t as 6.639, which we can round to 2 decimal places as 6.64. So this is in years, so we put time equal to 6.64 years. Now we can go ahead and fill in into the box. It is 6.64. So we have answered both the values of annual rate of interest and time to double.